All right, so Melissa asked me, what if we have a geometric sequence? Well, geometric sequence.
I didn't ask you that.
Myra did.
Oh, sorry, Mara did.
She's an example.
So let's say we have 3, 6, 12, 32. We do exactly the same thing that we do with the other one. What's the pattern?
Times 2.
3 times 2 gives me 6. 6 times...
Isn't it just isn't just like multiplying or dividing or
Yeah, it's multiplying or dividing. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 32. Wait, nope, 24. 24. All right, so I fixed it. So because it's multiplying, we know that it's what kind of sequence?
Geometric.
Geometric.
because 3 times 2 is 6, 6 times 2 is 12. Oh, I'm counting by 6, my bad. And 12 times 2 is 20.
Okay, if you were to count like you do with arithmetic, it wouldn't work because 3 plus 3 would give me 6, and then 6 plus 6 would give me 12, and then 12 plus 12 would give me 24. That's not a pattern, right? That's different. That's not the same thing. That's not the same numbers.
So geometric multiplies and then arithmetic adds.
Arithmetic add and subtract, geometric multiplies or divides. That's how we know it. So I'm going to use G for geometric. And then the formula for that is A sub 1 times R to the power of n minus 1. Well, you have to find this, you have to find that. That's all you need to find. Hang on. I'm about to explain it. Do not worry about this. I only use G because for geometric. That's it. Sub n. A1 is the value of the first term. A sub 1 is the value of the first term. What is the first term?
3.
3. R is the pattern. Is the common ratio. What's the pattern?
Times 2. Times 2.
So you put 2. That's all you need to know. Now we can just create it. So G sub n equals 3 because that's what A1 is, times 2 because that's what R is, to the power of n minus 1. That's the rule.
Or can you explain to me the n minus 1 thing?
Huh?
Can you explain to me the n minus 1?
Wouldn't it be like
That's to the power of. That's part of the formula. Now I'm gonna use it.
Minus 1, right?
Do what?
So basically that'll be 3 times 2.
To the power of n minus 1. I'll explain how this works because I know that's confusing you. So hang on before you jump into conclusions. Let me explain how this works. I told you put, if I ask you to find the fifth term, you would just put it in there, right? You plug it in. So G sub 5, because we're looking for the fifth term, correct?
Yes, sir.
It will be 3 times 2 to the power of 5 minus 1.
yeah, because they want
That's where the n is, right?
So it would be 3 times.
so it'd be 4.
Which would be 6 and then.
So it'll be
No, 5 minus 1 is not 6. What is it?
4. No, I'm not 3 times 2.
No.
Now, do not forget about your PEMDAS. Which one comes first? Multiplication or exponents? Exponents. So this is an exponent. This basically means it's 2 times 2 times 2 times 2. 4 times. When you see like that, you multiply it 4 times. That's what it means. Yes.
Oh, so why did you put the 5 minus 1?
Because that's part of the n minus 1. That's part of the formula.
Wait,
So-
why did you just put the little number on top?
Because you have to plug it in. If I'm looking for the fifth term, I'm going to put 5 wherever I see n.
Well, what's the 3 times 2?
Huh?
What's the 3 times 2?
Oh my god, it's the
That
It's the formula.
part of the formula. This is part of the rule. Okay, I'm going to go back. Hang on. I'm going to go back. Ignore this. This is the formula, right? Up here. And of the formula, we have to find these values. A sub 1 and R equals 2, right? I'm sorry, the common ratio. So we know that the first item, the first value, which is A sub 1, is 3, right? That's where we started. A sub 1 equals the first value. The common ratio is the pattern. And you told me the pattern is multiplying by 2, right? So we put 2. We don't put times, we just put 2. Now that we have these two, we can plug them in here. So we did that. We put 3 where a sub 1 is. We put 2 where r is. Do we get that? And we just bring down that n minus 2.
Yeah.
That's the rule. This is the rule. Now I asked you to find the 5th term. Right? All you do is substitute 5 wherever you see n. And you only see n up here, right? So that's where you put it.
So,
And then once you have that, you start working it out like PEMDAS.
so first you subtract 5 from 1, right? 'Cause it's a
1 from 5, yeah.
Yeah, okay. Oh.
And you end up with 4.
After that, and then after you subtract that, you multiply with 3 times 2.
No, you cannot do that. This is parentheses, right?
Yes,
Send it
sir.
to exponent.
But then you have to do exponents. You can't jump over here. You have to do exponents first. Remember PEMDAS?
Yes.
Parentheses, exponents. So we have to work this out first.
It's easy to understand.
So that's 2 times 2 times 2 times 2 because it's 4th power. So that's 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. So once you get that, you put 3 times 16. And what is that?
48.
48?
Sir.
You do g sub 5 equals 48.
So what's the trouble?
Yeah.
So every time it'll be minus 1, right?
Yeah. Yes.
What question how would you personally, like on a test, ask us to find this?
I wouldn't. I just told you that.
Yeah.
But you wanted to know how to find it, so I showed you how to do it.
Oh,
You
so
will
you're-
not be asked to do this. It's actually easier than the other one because you don't have to find the 0 term. You just plug in the numbers, right?
Oh, so on the test we forget
You won't
about
have that.
geometric.
All you're gonna have to do, they'll give you a formula and they'll ask you to use the numbers. They'll give you the formula like that, like this one right here. I mean a rule, and they'll say, I want you to find the 4th term. I need you to know that you have to plug in 4 wherever you see n or wherever you see x or wherever you see the letter. That's where the 4 goes. You're not gonna have to do any of this. You're gonna be given this part, and all you have to do is this part right here. You understand that?
Yes, sir. I get it now.
And the rules will not be always the same. They'll be in different shapes. It'll be n squared. It'll be something else squared, or blah blah blah. It'll be different, just so you know. And I don't think it's gonna go over second exponents. I think probably what you're gonna get is gonna be either something like this, or something like this plus 2, or n squared minus 5. Those are the formulas that they're going to give you. And all you have to do is plug them in. If they say find the 9th term, well, then you just put 8 sub 9 equals, let's use this one, 9 squared minus 5, which would be what? 81, right?
Yeah.
Minus 5. And what does it give me?
79.
Are you sure?
No, 76.
It's 76.
76. There you go. That is all you need to know about the geometric ones. I'm going to post this for the pre-AP because they need to know it. But I'm also going to post it for you guys so that you all can look at it and see if you want to learn it for next year when you actually go over it. And you have a little bit of prior knowledge to it. If not, then, I mean, that's all you really need to know as far as the geometric sequences. You don't need to know much about it.